And anyway, we'll go from there. So, all right, hand them in. Or you can just lock. I don't want to change anything. Did you miss points, right? So if I give you a 2-point quiz and you get a 1 out of 2, should I give you 50%, which is math? I hate that. Like you could get 99% on everything else, but if that has a heavier weighting, like I don't like that. Just so you know. I'm always on your side, but guess what? You gotta keep me on your side, right? And so far, they're close. That's good. Anyway, what? Number, what is it? Kylie, the floor is still sticky.
What? Hey, Tim.
Okay, is that good? That better? You see the board?
Like,
what?
Yeah.
Pretty good?
You could probably move it back a little bit.
Back it up.
Yeah. There.
Is that good? So here, here.
Yeah.
Oh, that's off the board. This is the end of the board. So we're good?
Yeah.
Okay, there's something I should tell you. Am I on? I'm recording. I'm wearing shorts. All right. Okay, what was that one? Number 21. Okay, is sine squared cosine 2x. Sine of that squared. Sine squared of cosine 2x. Okay, so we're going to do this a couple different ways to prove that the correct answer is correct. But anyway, so basically it's sine squared of something, right? So you would really rewrite that sine squared is like, this is like sine of that thing, cosine 2x. Sine of that thing, quantity squared, right? Do you agree? Because that's what sine squared is. We're taking sine squared of something. So anyway, I'm going to act like it's okay, and I would use what rule for f prime? What's the first rule I use? Power rule. So we drop the 2 down in front, that thing to the first power, right? So what is that thing? So it's sine of cosine 2x times the derivative of what's inside, right? I'm going to use different color here, hopefully. Times the derivative of what's inside. So the derivative of what's inside is sine of something, right? Sine of something. So the derivative of sine is cosine of that something. So this is cosine of the cosine of 2x. But since it's not just an x in there, so this is by the chain rule, right? By the chain rule, that blue part. So it's cosine of cosine 2x. But then you got to take it times the derivative of what's inside, right? Because it was sine of a function, not just sine of x. So what's the derivative of cosine 2x? Derivative of cosine is minus the sine. So times minus the sine of that thing, which is 2x. And of course, that's by the chain rule as well, right? But since it was cosine of a function, not just cosine of x, I also have to take it times the derivative of what's inside that, which is the derivative of 2x, which is 2. So times 2, and that's also by the chain rule. So this is the chain rule within the chain rule within the chain rule. Right? And so, John, I did have like multiple examples yesterday, where there's either 1, 2, or 3. I might have done one with 3 chain rules yesterday. Anyway, so then we just shuffle this together, simplify, and I can multiply those 2's together and the minus sign, and I get minus 4, right? Minus sign of the 2, that's minus 4. And then it doesn't really matter what order you have it in. Sine of the cosine of 2x times cos. Who is that? Times cosine of the cosine of 2x. Did you touch your face today? All right, sign it to it. Anyway, that's Hannah had that, so that is in some kind of order, right? That's good. You need a tissue. You need a roll of toilet paper. Well, we got paper towels. Yeah. This is on film. Like they can't see it, like we can't see it, but like they can hear it. All right. Anyway, let's do another thing here. So how else could we do this? If I wanted to let, well, basically it's sine squared of something, right? Sine squared of something. So what could I do? I could let, what color was I having? Yeah, we got that thing. Well, let's just say, how can we make this easier? Let's just make this easier and make sure we end up with the same answer. So everybody knows the answer, right? I need to give myself some room so I can write big enough for kindly to see. All right, but anyway, let's just make this easier. So let's go back to that dummy variable stuff. And instead of cosine of 2x, wouldn't it be nice to let that be something else? Okay, so z, sure. So let z equal 2x, okay? And then if I did that, what would I have? I'd have f of x equals sine squared of cosine z, right? Is that better? Is that easier on the eyes? It is, right? So, but it's sine squared of something, so now what could I do? Now what could I do? Well, instead of cosine z, instead of taking sine squared of cosine z, what could I do? Let, like instead of a function there, I could let it be something else, right? But I got to pick a different letter, u. So let u equal cosine z, right? And if I do that, I just plug u in there. So does that make this easier? So this is, basically I put z in for the 2x, right? Up there. But sorry, let me keep going. So f of x, so I haven't taken the derivative yet, is sine squared of u. Is that easier? Everybody agrees, right? That's easier. That's a better deal. Okay. But then this we can also think of as sine of u quantity squared. Correct? So what can I do here? Instead of a function to a power, well, we could use the power rule, which has to use the chain rule, but I'm trying to use a dummy variable. I just wanted something to, not a function squared, I just want a letter squared. So what letter do you like? G. G. Okay, G, usually when we have G, F, H, things like that, but when we have dummy variables, we're using the end of the alphabet usually. So I don't care, you can call it anything you want. R? Yeah, R. Okay. I would have picked W, but that's me. Anyway, it doesn't really matter as long as you label it, right? So if R is sine U, what do I have now for your function? So now f of x equals R squared. Okay? So if I want f prime at x, so let's think about this. If I want f prime at x, that's df, the derivative of f with respect to x, right? Everybody agree? But I can't do that because what's f in terms of? R. So what would I have to do? I could take the derivative of this with respect to r first, right? So I could say this is df dr times, and then what's r in terms of? U. Let me just keep it blank. So df dx, which is what I'm trying to get, is, well, I can take the derivative of f with respect to r, but then r is in terms of u. So I can take it times dr du, right? And so what's this really like? This is really like df du, isn't it? And then what's u in terms of? Cosine is in terms of z, right? It's some function of z. So I can take it times du dz. Everybody agree? Now I'm still not at the end. I need an x at the end. And then what's z in terms of? It's in terms of x, so I can take it times dz, the derivative of z with respect to x. And all these in the middle essentially cancel out, right? Essentially is how we're thinking of the chain rule. They don't really, but I mean, they kind of do. So anyway, basically we're trying to do all that. And this is using the dummy variable, but you can see this is a lot more involved version of it. But if you're getting lost, this is an easy problem to get lost in the confusion of the awkwardness of the trig signs of a function, right? So this actually, going back to Isaac in his concussion days, actually kind of like this, right? That hasn't been proven. What? You didn't know concussion. You didn't. No, you didn't knowingly have a concussion. I know. Okay. So anyway, what's this equal? So df/dr is what? Let's just do it. We'll go around the room. We'll start with Kylie.
What?
What's df/dr? F of x is r squared. What's the derivative of that with respect to r?
2r.
2r, right? So it's 2r. Everybody good? So that's this one. That's in. And then what's next? dr du. Can I do that in green? Let's do that in green. So who's next? Hannah? It's cosine of u. Derivative times cosine. So dr du is times cosine of u. Does everybody see how easy this is getting? Like you thought this dummy variable stuff was dumb or stupid, but you're not supposed to say that word. And the times du dz. Back to Jordan already. What's u is cosine of z, so what's the derivative of u with respect to z? Negative sine what? Negative sine z. So the derivative of cosine z with respect to z is minus sine z. Everybody good? And then last but not least, hello, we have, I'm going to do this one in purple, I guess, z equals 2x, because I did the first one in black. So z equals 2x, red if you have it. I don't know where the red markers are, they're probably over there. But anyway, z equals 2x. The derivative of z with respect to x, the derivative of this function with respect to x. What's the derivative of 2x with respect to x? Isaac? 2. Times 2. And that's this one. And there's our answer. The problem is, I want it in terms of x, so I have to change everything over. If you change everything over, r is sine u. So let's do this. So this is 2 times r is 2 times sine u, correct? And then cosine of u, what's u? So this is times cosine, instead of u, is of cosine z. So cosine of cosine z, right? That's what the green box becomes, times, what's the blue box become? Instead of negative sine z, it's times negative sine of what z? 2x, right? And by the way, these are all times, so this would be in parentheses, right? You can't, you're not subtracting it, you're multiplying it, right? So anyway, I didn't show it here because I put box around it, but really it's multiplication. So it's times that, and then times what? Times 2. So that doesn't need to change the variable. So we're getting closer, right? So let's do this a couple of more times. So 2 sine u is what? Instead of u, sine of u, what's u? So it's 2 sine of cosine z, right? Times cosine of cosine z, but what's z? Cosine of cosine 2x, right? And then instead of, and then times minus sine 2x. And then times 2, right? So we're close, we're almost done. So let's still got times 2 there. Anyway, and last but not least, let's do it one more time. Get rid of that last z. So it's 2 sine of, instead of cosine z, what's z? It's 2x, right? And then the rest, we already did it. So it's already in terms of x. Cosine of cosine 2x times minus sine of 2x times 2. Okay, whoops, I didn't do all that. I didn't keep my color coordination. But that's it. And then if you simplify it, we can, the minus sign and the 2 can multiply together to minus 4, and the rest is 0. You're good. So hopefully you followed this a lot better today than you did 3 days ago. If you did, that means you're learning. If you don't, that doesn't mean you're not learning. That just means it's still a little bit awkward for you. You got to spend time with this stuff and go through examples and follow it. But this is where I'm saying it's, you can't learn by watching. Now you just did, right? I don't want to say that, but you're going to forget half of what you learned today tomorrow, and you're going to lose 3/4 of it by Monday. So you only retain like 1/4 of what you hear from today to Monday. And the stuff that you're going to remember is, oh, Professor Rao wore shorts, Hannah went to the bathroom, and Isaac has a concussion and snotted all over his mouth rag. Okay? That's what you're going to remember. And then like the 3/4 of stuff that I want you to remember, you're like, what? Right?
Don't have a concussion. I never did it.
No, I know. I'm not spreading any rumors.
Okay.
Right?
Yeah,
You should.
I'm positive.
Does Big Tig's elbow hurt?
I think you'll get it.
Does it still hurt him?
No, I don't think his elbow ever hurt.
Then you took the entire part of that hit. Oh, all right. Well, that's not it. Okay. Have you got him back yet?
Yeah.
Have you got exacted revenge?
No.
I'm not suggesting that, Big Tig, if this is on film, he should just forgive you as a good Catholic Christian kid. Okay? All right. So anyway, all right. Any questions on that? Do you like it? Who likes it? If anybody struggles with that problem, go do it this way and make it where, you know, the most inside thing, call it a different variable, right? And then keep doing it. Keep doing it. That makes sense? Now, did we, as John said, you know, when we had sine squared u, did we need to redo that? No, you didn't have to, because that's just 2 sine u times the derivative of sine u is cosine u. So we didn't need that r part because he knew how to handle that with just the chain rule. Right? And that's true. We could have just done that and eliminated the whole crap with the r's in there and then only had 3 of these things instead of 2. So once you get it to a point that you know, it's not that bad. In fact, let me prove it to you. Instead of saying this, we're going to take this u all out of there. Okay, so we got this. So if I'm going to do f prime based on sine squared u, we did this one yesterday, right? So it's 2 sine u times derivative of sine is cosine u. But then we got to plug back in what u is. So what's u? Cosine z. So it's 2 sine of cosine z times cosine of sine cosine z, right? Everybody agree?
Yeah.
And then what's z? Z is 2x. Uh-oh. What happened?
Didn't get that too.
Anybody can't do that. Why can't I do that? Huh? Z is 2x. Well, if I plug in z is 2x,
Yeah, you'll still get the same thing. Same thing once you get to the Z.
Because it's the same as the one.
Oh, no. What?
It's the same as the answer down there.
Well, it's not, because I have -4, so what I'm gonna get.
It's because you have the 2 up there.
The derivative of z is 2.
That's why.
Don't you add the 2 on the end there? Like you did on the other? You think you don't?
Well, yeah, but if I just took the derivative of sine squared of u, it's 2 sine u cosine u, right?
The derivative of the other one times. You did in the fraction thing. In the-
Oh. Well, but so what I'm saying is this doesn't end up being equivalent, because if I plug in z is 2x, it's 2 sine cosine of 2x, cosine of 2x, and you're missing some stuff. So we can't do that. Apparently.
We're not
We're just
gonna
gonna
do
do the other stuff too.
you didn't finish that one.
Like the right corner, you just eliminated one of the fractions.
I eliminated dr du.
You have to do the other.
Well, then I
one.
also eliminated dz dx, I suppose. Yes, I did. So I'm not using the chain rule if I do that. Okay, so I apologize. This is the third time, the second time in my life I've been wrong. I didn't know about the first two. So this is the first time in my life that I said something out loud that wasn't correct. First was Isaac had a concussion. Second, but I don't remember that. Second is we can't just like stop. You gotta do it all the way if you're gonna use a dummy group. Apparently, right?
You can't mix them.
Apparently you can't just go halfway with it. You gotta change it all over to something that's very easy to do so that you have times the derivative of what's inside. Otherwise, I'm losing the derivative of what's inside. Like I never did get the derivative of 2x there. Did I? If I change the z over to 2x, I gotta have that dz dx on there. So I gotta be a little bit careful here.
I think you still have that though.
It still would?
You would just get rid of the DFDR and DRDU because you got rid of the R.
Okay, so I would just have df du.
Yeah, you have to.
Oh.
Yeah.
Oh.
That's
Oh. Okay, so what did we have? Well, maybe I was right then. Maybe I will be right. Let's see. df du is what? 2 sine u cosine u, right? So I had that 2 sine u cosine u, and then I changed that over. But that's just df du. I still need to attach a du dz, right? Which is, so time, and that's what I didn't have. So times, what's the derivative of cosine? Negative sine of z, yes, times dz dx. Thank you. So I was missing these. I just left them off. Yeah, I know. Jordan, you said it 3 times. Thank you. You know, this is what, not to warn you, ladies, but this is what marriage is like. Guys don't listen, right? Until they figure it out for themselves that they're wrong. So anyway, when Lisa and I argue, like eventually we just stop arguing. Like we almost don't argue ever anymore. You know why? Because I know I'm right and she thinks she is. And she would tell you the exact same thing. Obviously, eventually I'm gonna know what I'm doing, right? So sometimes I just like to do the hard thing. All right, but anyway, so in that case, yeah, so we're still using the dummy variable, so we're okay as long as you don't forget about the other stuff that needs to be part of that. Thank you. Everyone noticed that except for me apparently. Kylie, I have no idea if you noticed it. Like you knew the whole thing, right?
What'd you say?
Why are you working on a paper?
Huh?
Why are you working on a paper? I can see it in your glasses.
That?
Oh.
Writing some notes?
Oh, you're taking notes off what I said? Well, only take notes on what I said up front. Okay, perfect. Okay. So I like that. Anyway, 2.9, we're getting back into word problems, related rates, things like that. So I looked at a couple of them. Number 13 is wrong in the back of the book. So I did that one in a video. Normally I don't like, I try to do all my videos where I'm not book specific because as you know, this book is old and crinkled but free, much like your professor. But, anyway, we're taking the derivative related to something else. So like, we might have a derivative with respect to t. In fact, we can do this. So this is also the chain rule that's called related rates. If I've got x squared plus y squared equals z squared, let's just do a quick example in section 2.9 here because I'm running out of time and I gotta go call. Then you guys like lead block for me so that Principal Pete doesn't see me in short. Anyway. Yeah. Anyway, if I want to take the derivative of this thing with respect to t, you can do the same thing to both sides of the equation. I can add 2 to both sides. I can divide by 2 on both sides. I can take the derivative with respect to t of both sides. Right? Now, but z, x, and y are all functions of t. So x is actually x of t. And y is y of t, and z is z of t. So these are all functions of t. So x could be like the square root of t squared plus 4. Y could be t cubed minus 3. And z could be e to the t power plus 1. Right? I'm really sorry I'm on it. That was because like I didn't want to miss class. It would have been much. I sacrificed myself for your benefit. Your Jack, yours too. Luke, yeah. Carter. Why are you so quiet? You're supposed to be. Isaac so loud. Anyway. All right, so if I do this, what do I got? You act like it's okay, right? So this is really x of t quantity squared, but it's the general, it was like when you had f of x quantity squared. How do you take the derivative? You gotta use the chain rule. 2 f of x to the first times the derivative of f of x, which is just f prime at x. So if I'm taking the derivative of this, what's this equal? What's the derivative of 2x with respect to t? Excuse me, what's the derivative of x squared with respect to t? 2x, you act like it's okay. So it's 2x to the first power times the derivative of what's inside, which is x, or really x of t. So I'm taking x prime at t, but instead of writing it as x prime at t, it's the derivative of x with respect to t. So since the variable is x, not a t, I'm going to attach dx dt by the chain rule. So really that's the chain rule. They call this implicit differentiation in section 2.9, but implicit differentiation is no different than the chain rule. It's a different terminology for the chain rule. But x is your variable here, but the variable that I'm taking the derivative with respect to is t. So we're assuming that x is a function of t. Yeah, act like it's okay, so it's 2x, but I'm taking the derivative with respect to t, so it's dx dt, right? Now, do you want me to? I'll show you one more way of why this has to be okay. Let's just take that one in green and go over here, and let me call that f of x. So f of x equals x squared. Correct? So some function x. So really, but x is a function of t, but whatever. Anyway, if I want the derivative of f with respect to t, which is actually what I'm doing here. The derivative of the sum is the sum of the derivative, right? So I'm taking the derivative of x squared with respect to t is df dt, right? Because f is x squared, so I'm taking df dt. But what is that by the chain rule? How can I really redo that? I've got it in terms of x, so I can take the derivative of f with respect to x times. Yeah, but I'm not getting the answer here. I'm getting the times dx dt, right? So this is the dummy variable version of the chain rule that we just stepped through, right? So all my madness has a purpose and all comes together at the end of Calc 2. Stick around. All right, but anyway, so we got this, right? But it's df/dt. Don't look around like you're not taking it. I already signed y'all up, so you're fine. Anyway, Independent study. Bring it on. What would you do in the spring? Anyways, we do this. So does that make sense? So what is DXDT? What is DXDT? What's DXDT? And then what's DFDX? What's the, yeah, it's 2x, so times DXDT, right? So that's where that comes, that's a long story short of, hey, I'm taking, act like it's okay, the derivative of that's 2x times, since I'm taking the derivative with respect to t, times DXDT. I still got a minute, plus what? What's this one? 2y times dy dt, and that's also by the chain rule. They're calling that implicit differentiation, but really it's a chain rule. What's that equal? That equals 2z times dz dt. Okay, so once again, they call that implicit differentiation, and then they're going to give you different word products, stuff like that. So you do have videos. So I want you to read 2.9, watch my videos, do some odds, try the evens, bring questions you have together, and then also I'm gonna, if you could watch 210 videos, I know you have a life too, but I don't care. So, right? I mean, it's not like you're gonna go golfing today, like I am. I do have, and then I'm gonna finish on this final note. I should probably talk about it tomorrow. Maybe I'll talk about it tomorrow because I'm out of time. The 90% rule. So remind me, the 90% rule. If you guys want, I'll take your assignments, please. 90%, I'm just gonna keep that up there, and you just gotta remind me to talk about it tomorrow. Thank you. Thank you.
Yeah, I think go with.
Thank you.
7 and 2 8.
Yep, 27 and 28. Hey, do I got 27? No, I said to hold it. All right, see ya. You good?
Yeah.
Kyle?
I was gonna tell you, there's a possibility of some new research coming out that antibodies don't expire.